G'day team, welcome back. We are still continuing on with our polynomial work. Today we're going to be looking at factorising cubic polynomials. And if you're following along with that hazy textbook, so it's in that 11 methods textbook. Oh, I'm just drawing all over my work. 11 methods, and it's chapter 4C we're looking at today. So just like we have methods for factorising quadratics, we can also factorise cubic polynomials. But what does a factorised cubic polynomial look like? So we've been doing a lot of work with cubic polynomials in the terms of x cubed plus 2x squared plus 3x plus 4, all right? But what would that look like in factorised form? So like I said, we've seen it in expanded form, so I've just written a very general cubic polynomial there, and remember that coefficient of that x cubed term cannot be 0, otherwise we do not have a cubic polynomial. So let's have a look at an example. So we're actually going to go from factorized form to expanded form. So we have 3 linear factors here multiplied together, okay? The way we do this, we ignore one of the linear factors to start with. So at the moment, I'm not worrying about that x plus 3 factor. And I'm going to expand these 2 binomial factors, okay, as I would normally with quadratics, okay? So you've done plenty of that. So you can use the FOIL method, you could use, if it's a difference of perfect square, you could use that. So by the look of it, we need to use FOIL. So that's what I've done. So first, and then I've skipped a step. So I've already collected my like terms of x. So x take away 1 multiplied by x take away 3 is equal to x squared take 4x plus 3, and then we've still got that linear factor of x plus 3 multiplied, okay? Now we're going to expand those 2 brackets, okay? Start by multiplying x squared by both terms, and then negative 4x by both terms, and then 3 by both terms. You'll end up with something a bit like this, so x cubed plus 3x squared, take 4x squared, take 12x plus 3x plus 9. All right, it's a bit of a mouthful, but there are a heap of like terms here, so we can actually simplify this down. If you're collecting like terms, our final cubic polynomial looks like this. X cubed, take 2x, take x squared, take 9x plus 9, okay? So in reverse, the process of writing x cubed take x squared, take 9x plus 9 as those 3 linear factors multiplied together is what we call factorising. So it's exactly the same as we did with our quadratics. This process is a little bit trickier than quadratic factorizations, okay? But it can be made a lot easier if we know one linear factor. And a lot of the time, you will be told this linear factor. So we're going to go through 2 different examples of questions you might come across when it's asking you to factorize cubic polynomials. The first one will look a bit like this. So it'll ask you to fully factorize and give you a cubic polynomial that looks like this. So mine today is x cubed, take x squared, take 6x. All right. So I'm going to rewrite that as x multiplied by x squared, take x, take 6. Because there is a common factor of x in all 3 terms, we can pull that out the front. So x is a factor. And then we're just left with a quadratic in here. We know how to deal with quadratics. We've been factorizing quadratics for a while now. So we're going to sums and product this bad boy. And we're going to end up with x multiplied by x plus 2 times by x take 3. So we've still got 3 linear factors. X by itself is a linear factor, okay? But see how we've got 3 linear factors. So this is x cubed take x squared take 6x all factorized, okay? So it's fully factorized in that form. The next example will look something like this. So given 3x take 2 is a factor of 3x cubed plus x squared take x 8x plus 4, fully factorize the cubic polynomial. So if you remember back to the video of polynomial introduction, we can write any polynomial p of x, okay? So p of x is equal to x take alpha, so a linear factor, times by, a new polynomial, okay? So because we're told one of our factors of our polynomial, okay, we can write our cubic polynomial 3x cubed plus x squared take 8x plus 4, and we can write that as 3x take away 2. All right, that's our linear factor multiplied by some general quadratic polynomial. We know it's going to be a quadratic because we've pulled out at least a factor of x, so all our powers will at least drop 1. So we're left with a general quadratic. So now we need to solve for a, b, and c. In the last video, we got you to practice equating coefficients, and that is the exact skill we're going to use here, okay? So we're going to expand out that right-hand side. So it does look a little bit messy, but remember we're just multiplying this first term in the binomial, okay, by the 3 terms. So 3x times ax squared is 3ax cubed, all right? And then you're multiplying that by bx and then by c, and then negative 2 gets his turn, and negative 2 is multiplied by the 3 terms, okay? The next step now is collecting like terms, okay, and then pulling out that factor of x squared or x. So I've gone done that here. So 3ax cubed is the only x cubed term. We've got 2x squared terms, so we can pull out those coefficients out the front, multiplied by x squared. Same thing with our x, and then we're left with negative 2c on the end. Now this is where we start our equating of coefficients, okay? You can set it up however you like. I like to set it up this way because it's really easy to follow. As long as it's really clear what you're doing, then I'm happy for you to set it up either way. X cubed and the constant terms are the easiest to deal with because you don't have to substitute another piece of information. There's only one unknown. So I like to start with the x cubed term and work my way down. So looking back at our original cubic polynomial, we can see that the coefficient for the x cubed term is 3. So we write that on the left-hand side. And that is equal to the coefficient of the x cubed term on the right-hand side, which is 3a. If we solve that for a, we know a is equal to 3 divided by 3, which equals 1. All right, so a equals 1. Now I'm going to look at the x squared term. All right, so 1, looking back up here at the coefficient of the x squared term on the left-hand side, and then the coefficient of the x squared term on the right-hand side. So we say that they're equal to each other. We know that a is equal to 1, so we substitute that in. That's why we've dropped that a off here, because it's 2 times 1. We don't need to write that 1 in. If we then follow the process of solving for b, add 2 to both sides, divide through by 3, you see that b is equal to 1. Do that same process with the x term. So on the left-hand side, the coefficient of x is negative 8. On the right-hand side, it's 3c take 2b. We know b is equal to 1. We just found that out. So again, substitute that in. Add 2 to both sides. Divide by 3 on both sides, and you find that c is equal to negative 2. We have found all 3 unknowns, but it's really good to do a double check. So I always substitute c into the constant term. So the constant term on the left-hand side is 4. On the right-hand side, it's negative 2c. And again, we find that substituting in negative 2 for c, 4 equals 4. That's a big check in my book, okay? So writing those a, b, and c into our quadratic. All right, so a is equal to 1, b is equal to 1, and c is equal to negative 2. We can say that 3x cubed plus x squared take 8x plus 4 is equal to the linear factor they gave us, so 3x take 2, multiplied by the quadratic we just found the coefficients for. All right, so now we need to double check that we can factorize this quadratic a bit further. Turns out we can, so our cubic polynomial factorizes all the way down to these 3 linear factors, 3x take 2 times by x take away 1 times by x plus 2. All right, so if you are following along with the Hazy textbook, have a crack in 4C at questions 1 through 5. All right, guys, we will see you all next time.